Could you please define inertia?
Inertia is the tendency of an object to resist a change in state of motion. At least that's what the book said, but I don't get it. What's a state of motion?
A state of motion just basically means velocity.
Oh, so a change in state of motion would be a change in velocity.
Right, and change in velocity over change in time is acceleration, so inertia is a resistance to acceleration.
Right. Inertia is the tendency of an object to resist a change in state of motion. A change in state of motion is acceleration. Therefore, inertia is the tendency of an object to resist acceleration. For example, the steel sphere on your left is at rest, and its inertia will cause it to tend to stay at rest. The steel sphere on your right has a constant velocity, and its inertia will mean that it will tend to maintain this constant velocity. And the constant velocity means a constant speed and a constant direction.
How does mass come into the second law? This science stuff is very serious. One ball is wooden and the other is brass. This time we have 3 balls. We're adding a ping pong ball. You can see here that things with more mass move more slowly. The second law says there's a connection between force, mass, and acceleration. So, if you apply the same force to objects of different mass, they will accelerate differently. So, Newton's second law states that force is proportional to mass and acceleration. So the greater the mass, the slower an object will accelerate when the same force is applied. Pedro blows the balls with the same breath, but their different masses mean they move at different speeds. Newton's second law is easier to demonstrate on the ISS, but here on Earth there are other factors to complicate things.
There are a lot of misconceptions out there, and this is a video about one of the most common ones. So I went around asking people what makes the moon go around the Earth, and they told me
the Earth puts a gravitational force on the moon.
But does the moon put a gravitational pull on the Earth?
Pull on the Earth? Yes, it does. Hence we have tides, etc.
The moon pulls on the Earth too. It affects like the tides and women and stuff. It does. Very powerful, this thing.
Does the moon pull on the Earth?
Probably that as well, yeah.
So what I want to know is how does that force that the moon exerts on the Earth, how does that compare in terms of size to the force the Earth exerts on the moon?
Well, I'm no scientist, but I think that one would be more powerful than that one.
It's got a greater force coming from the Earth because it's a greater mass.
Because the Earth probably has more mass.
Because it's a bigger mass. I thought greater mass is equals more force.
Does the moon pull on the Earth?
Yes, but a lot less.
Yeah, not as much as the Earth pulls on the moon.
Yeah, but a little bit.
But not very strongly.
Yes, but much, 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 much smaller.
Because of its mass,
less
its
mass.
size.
Because it's smaller, it's much smaller than the Earth.
Because it's smaller.
Is it small?
Allow me to let you in on a little secret. Everyone got it wrong. The force that attracts the moon to the Earth is exactly the same size as the force that attracts the Earth to the moon. So what's going on here? Why did everyone get it wrong? Well, I think it comes down to cause and effect. The effect of the force on the moon is quite clear. The moon goes in circles around the Earth. But the effect of that force on the Earth is basically negligible. The Earth barely wobbles at all. So people interpret this negligible effect as indicating there's very little force affecting the Earth. But that is forgetting the third key piece of the puzzle, which is inertia. Inertia is the tendency of mass to maintain its state of motion. Since the Earth has a greater mass, it has a greater inertia, and so even with the same amount of force on it, it doesn't accelerate that much. Now the funny thing is, many of the people I interviewed could state Newton's third law, which is every force has
an equal and opposite reaction.
Something about Newton's law doesn't seem to fit into that. You're good at this.
Which Newton's law are we talking about?
The whole equal and opposite force thing. Yeah, that one.
So tell me what you're thinking now.
Well, one would think that if the Earth is putting a force on me, I would be putting an equal force upon it.
So why didn't they apply it to this problem? Well, I think they may have memorized the words, but not really believed Newton's third law in their core. Did they really feel it in their spleen? I don't think they did. So, allow me to try to convince you, all of you, spleen included, that Newton's third law really is true. Let's consider two objects. Initially, they have the same mass, 1 kilogram each. So obviously, the gravitational force of attraction must be the same on both of the objects. Now let's add a second kilogram to the first object. The force on the second object will now be twice as great because that 1 kilogram is attracted equally to each of the kilograms in the first object. But what is often forgotten is that new kilogram is also attracted to the second object, meaning that the total force on each object is still the same. They're attracted to each other with an equal and opposite force. We could add a third kilogram and we would find the same thing. The force on both objects is still the same, even though the object on the left has 3 times the mass of the object on the right. So we can see that no matter what the mass, any two objects will have the same gravitational force towards each other. Can you feel Newton's third law in your spleen now? It should settle inside you and become a part of you.